All right, so here we're going to go over our angled projectile example in your notes. You already tried to solve this in your notes, and here I just wanted to go through the solution in case you didn't get it. In this problem, we were launching a projectile from an angle, and here we're just working in variables. So we're going to try to end up with an expression here for time in terms of initial velocity, acceleration due to gravity, and the angle in which it was launched. And we're just trying to figure out how long it's in the air. Let's go through the things we know. We know that the initial velocity vertical was velocity initial times sine theta. That's just the vertical component of our initial velocity. And we're going to use our end time to be our vertical velocity at the peak, which we know is going to be 0 meters per second. So we're going to work with and try to find the time it takes to get to the peak, and then we'll double that time. Our acceleration vertically is going to be g, and we're going to find time to the peak, because once we find time to the peak, again, we'll just double that time, and we'll have our problem solved. So when we're trying to figure out the time of flight, it's just vertically dependent on the motion. There's no horizontal component. That's why we're using the sine part of it. And we're going to use our kinematics equation that says that final velocity is equal to initial velocity plus acceleration times time. Plugging in the values we had from last time, or rearranging the equation for time to the peak, we would say time to the peak is our final minus initial divided by acceleration. Plugging in our values that we already established, final velocity is 0. Our initial velocity is vertically is just our initial velocity times sine theta, and then we divide that by acceleration due to gravity. So this is going to give us the time to the peak, and we can use this for any scenario where we would have some angle, some projectile. We want to know how long it gets to the peak. We could always use this equation. Working with this equation, we're just going to simplify it by getting rid of the negatives and then the initial velocity, and just say our time to the peak is our initial velocity times sine theta divided by acceleration due to gravity. And since our total time is twice our time to the peak, we can just multiply that by 2, and our answer then would be 2 times initial velocity sine theta divided by acceleration due to gravity. And that is how long it would take any projectile to rise up, come back down to the ground if it's launched at an angle.